So many people think of light gauge steelwork, they think of light gauge steelwork as purlins in the roof to support the rafter, or side rails to support the cladding. But in the UK, light gauge steelwork is used in many more applications. So this is light gauge steelwork, and it is being used in residential construction. Sometimes these panels will be erected, I'd like to say that again. Sometimes these panels will be assembled in the factory and then erected as complete panels, as you see here. Sometimes they will simply be assembled on site. The advantage of this sort of construction is there is lots of room to insulate the walls. So compared to masonry construction, this is a very efficient approach, and it's very quick. And it produces residential construction of the form that you would see there, and you would not know that there is a steel frame within each one of those structures. We also use light gauge steelwork in multi-storey construction. So it may be that the cladding on the elevation is supported by some light gauge steelwork, and maybe the internal finishes are also supported on the light gauge steelwork. It's very quick. It has the opportunity to insulate the elevation. In this case, there are a lot of prefabricated balconies, again out of light gauge steelwork. A lot of light gauge steelwork is used in a three-dimensional module. So these may be assembled one on top of the other, maybe for a school, maybe for a hospital, maybe for accommodation for students. Many multi-storey buildings are now made out of modules. Some of these modules will have the electricity supply, some of them will have the plumbing, some of them will have the heating before they ever appear on site. They may then be lifted in to a multi-storey building. This is the final use of light gauge steel, so quite a lot of roofs, even on relatively modest structures, are now constructed from light gauge steelwork. So these are typical profiles. Many people roll these profiles. You do not need much equipment to be able to roll one of these light gauge cross sections. So maybe 1.2 to perhaps 3 millimeters. You can see the dimensions. For the walls, maybe as low as 1 millimeter. C sections would be a very common cross section to be used. And again, for floors, C sections or sigma sections. In the UK, they would always be galvanised. So the original piece of steel would be galvanised and relatively high strength steel. How then do you design these members? Well, ladies and gentlemen, there is probably a longer course for you to look forward to on the design of these members. But they are covered by the Eurocode, of course, a different part of the Eurocode, 1993-13. And just to give you a flavour of how these things are designed, you cannot use the gross section properties because the members are just so thin. You always have to calculate some reduced section properties. So you start with the gross section properties, and then you calculate some effective section properties. So rather like we were discussing yesterday, sometimes you can neglect part of the cross-sectional profile. In light gauge steelwork, almost always you are going to neglect some part of the cross-sectional profile because they are so thin, they suffer from local buckling. So considering a cross-section, this would be local buckling. And we know that the areas adjacent to the corners are relatively stiff, and perhaps somewhere in the middle we would then neglect. The second problem is called distortional problem. So not only do between corners deflect, we also get some distortion of the entire cross-section. And to allow for this, the Eurocode says we will reduce the effective thickness. So there are two methods. For local buckling, you neglect certain parts of the cross-section. For distortional buckling, you assume that certain parts have a reduced thickness. So there is the illustration of local buckling. Adjacent to the corner, we have an effective breadth. So this whole idea of effective breadth is really important in the Eurocode. And away from the stiff areas, then we neglect part of the cross-section. The reduction can be quite significant. So if we just consider the inertia, there is the inertia for the gross section properties, 41.7. The reduction due to local buckling brings it down to 34.9, but then a further reduction due to distortional buckling brings it down again. So clearly, you cannot design using the gross section properties. You have to design using reduced section properties. Once you have the reduced section properties, it's just like we have been doing for 2 days. We consider the cross-section, we consider the buckling behaviour, and you will be referred back to flexural buckling that we saw yesterday. You will be referred back to lateral torsional buckling that we saw this morning. There is guidance available, ladies and gentlemen.